Hello and welcome to Shudeepa tutorial. This is Chapter 1, Grade 9 Science, Matter in Our Surroundings. And this is the Module 3 video of this topic in which we are going to discuss in details about the density of substances. But before we start, let's recollect what we have studied in Module 1 and Module 2 videos of this topic. If you have missed watching them, kindly visit the two videos. Also solve the assessments that are provided in the description box below. In the previous two modules, we have discussed about the states of matter, that is solids, liquids and gases, and how to differentiate among the three states based on these 11 properties that are listed down. Today's topic of discussion is density. But before going into the details of what is density, what are its units and real-life connections, let's see a very few simple examples from our day-to-day life. All of you must have at some point of time added water and honey and also water and oil. What's common between these two pictures on the left and right? Yes, you are correct. It's water. Water, as you know, is a universal solvent. So most of the things dissolve in it. When you dissolve a few spoonfuls of honey with water, you will find it settling down immediately after it comes in contact with water. Is it the same in case of oil and water? No, you are right. When you try to dissolve oil in water, you will never find it going at the bottom like honey. Instead, oil is always found to float on the upper surface of water. Again, notice the differences between the two stones. The one which is present at the top, almost floating, is the pumice stone, and the other, which has settled at the bottom of the beaker, is the marble. Question is, why are these two stones behaving differently, or why are honey and oil behaving differently with the same solvent, that is water? To know more, let's look at these two examples in figure A and B. These two yellow boxes that you see is actually cubes or cuboids, whatever you take. But the thing that you have to notice over here in figure A and figure B are that the volume of these two cube or cuboid are same. That is, the product of the length, breadth and height remains same for these two vessels. Now observe the spheres that are present, the red color particles that are present. These red color particles are analogous or same to molecules, which makes up matter. What do you observe in figure A and figure B? In figure A, the number of particles present in the same volume is more than the number of particles in figure B. Hence, we can say that the density of A is more than the density of B. So let's define density. Density is defined as the mass per unit volume of a substance. Let me repeat it, mass per unit volume of a substance. So let's get back to the figure A and figure B again. So when I'm talking of mass, I'm actually talking of the mass of the particles, that is the mass of the molecules present in the same volume of A and B. So I'm repeating the definition of density once again. Density is defined as the mass per unit volume of a substance. Now, if you have to calculate the density of any substance, what should be the formula? Density is equal to mass upon volume. In short, it is written as D is equal to M upon V, where D stands for density, M for mass, and V for volume respectively. Now, this part is very important. That is, what are the units of density? Generally, when we measure substances, we use either the SI unit or the MKS unit, as you can also say, and the CGS unit. Now look at the formula once again. Unit of mass in the SI system is kilogram, while the unit of volume, that is length into breadth into height, is equal to meter multiplied by meter multiplied by meter. So it is cubic meter or meter cube. Therefore, density in SI unit is kilogram per cubic meter or kilogram per meter cube. Similarly, in the CGS system, the unit of mass is gram. The unit of volume, that is length into breadth into height, is equal to centimeter cube or cubic centimeter. Therefore, the unit of density should be gram per cubic centimeter or gram per centimeter cube. Remember, in some cases, the abbreviation for centimeter cube is also written as CC, both in small. Let's see the effect of heat on substances, and remember, it is a very, very important phenomena for you all to understand. When substances are heated, the kinetic energy of the molecules rise. And when the molecules gain kinetic energy, they start moving faster. And gradually they drift apart. That is, they move away from one another. Now we have already seen that volume is the space occupied by a body. What happens is when the space occupied by the molecules increases, therefore the volume gradually increases. As you can see, there is an increase in volume in the second and the third figure compared to the first figure. But the number of molecules remain the same in all the three figures, the first, second and the third. But if you consider unit volume of the substance, then the particles are more in case of the first figure and gradually the least in case of the third figure. Therefore, we can say that if the substances are heated, it expands, the density gradually decreases. So it's very clear that opposite will be the phenomena when the substances will be cooled. Because when you cool the substances, that is, when you extract heat or take away heat from the particles, the kinetic energy of the particles will reduce and therefore they will move closer. So the number of particles or molecules per unit volume will increase. Therefore, the density will also increase when substances are cooled. But yes, there is an exception, which is a very common substance, that is water. And we will discuss about that in a short while. If you mix a large number of substances like honey, sugar syrup, dishwashing liquid, water, and edible oil, you can see the layers in which they are present. So it is very easy for us now to understand that honey is the densest, which is present at the bottom, and edible oil is the lightest, which is present at the top. In between lies sugar syrup, the dishwashing liquid, and water. So objects which are light or less dense will rise upwards, while the objects which are heavier or more dense will move downwards. Related to this, let us see a few examples. Look at this figure. You will always observe that the chimneys in the houses are fitted at the top. Similar is an example. You will see the exhaust fan in your mother's kitchen is always at the top. It is never at a level which is close to the window. Why so? Let's see a few more examples. The AC machines, that is the air conditioning machines, are always fitted at a level higher than the windows. Why so? Ice floats in water. Isn't it strange? Both are of the same chemical nature, that is water, but ice cubes float in liquid water. Why does it happen? Also, the first example when I introduced to you this topic, I discussed about the marble and the pumice stone behaving differently when it comes to floating or sinking in water. Why so? To answer all these questions, we have to think about the density of the substances. Now look at the first example and the second example, they are quite similar. Hot air, which is less dense and lighter, will always move upwards. And just now I have told you why hot air is less dense or lighter. This is just because air, when gets heated up, it expands, and therefore the number of particles or molecules of the gas per unit volume becomes less. Therefore, the density becomes less. When the density decreases, it will definitely become lighter, and hence it will go upwards. Therefore, if we have to release any kind of exhaust gas either through the chimney or through the exhaust fans in the kitchen, it should be located at the top. On the contrary, I had told you that air, when it is cold, it is more dense. The AC machines which are fitted at the top of the window release cold air, and cold air is heavier, therefore it settles down, it comes down, allowing a comforting condition to the inhabitants of the room. Now let's take this example. The pumice stone. I think most of you have seen what is a pumice stone. It is used for the purpose of cleaning. It is also used as a foot scrub. There are holes in the pumice stone, small pores in which the air gets trapped. And when air gets trapped, the weight of the stone reduces. Therefore, the pumice stone floats up, while the marble, which is heavier and more dense, gradually sinks. That is why the pumice stone and the marble behave differently. Now, let's come to this example. When I was explaining you the expansion and contraction of substances when heated, and I had said that there is an exception to this, that is water. The general condition is when you heat a substance, it expands and becomes lighter. On the contrary, when you cool a substance, it becomes denser and heavier. But in case of water, this is slightly different for a certain range of temperature. This behavior of water is very strange and is called as anomalous expansion of water. In this case, you will see when water condenses to form ice, though the volume increases, the density decreases. And because the density decreases, ice floats in water. You can see in this diagram, ice is at the topmost, and you can see the molecular arrangement and the space between the molecules. And you can also see the location of warm water and cold water. Cold water is heaviest and is present at the bottom, while ice, which is actually a solid form of water, should actually be down but is present on top. Because the density of ice is lesser than that of water, it floats in water. Remember this behavior of water, which is called as anomalous expansion of water. The anomalous expansion of water is actually a blessing for the aquatic animals. It allows the aquatic animals to survive in the lower layers when in the winter season the upper part of the water bodies turn into frozen ice. The lower layers of water is still in the liquid state and the aquatic animals can comfortably survive there. Like, share and subscribe to Shudeepa tutorial. This is all for today's video, but don't forget to click onto the assessment link in the description box below. Kindly solve the 3 assessments of module 1, 2 and 3 in my module videos. It will definitely support you to improve. Thanks for watching.